Hello kids, today I'll talk to you about steps. So in school we've had this assignment where we had to talk about how many steps we take in a day because we use our pedometers. Let's look at the questions, shall we? Number 1. Based on your experiences from last year or just a common sense guess, how many steps do you think you walk per day? Looking back at my pedometer spreadsheet and looking through all the numbers, I think around 15,000 to 20,000. Between those two numbers, I think I walk about that much on average. Number 2. How does the day of the week affect the number of steps you take per day? When I have sports or I hang out with my friends, I get more steps than when I just come home right after school. Number 3. How would you go about calculating how far you walked based on the number of steps you took in a day? Write out your directions for calculating the distance walked in a given day. Be sure to make the directions specific and clear enough for anyone to follow. Why don't we take a look at the computer screen? So the question is, how would you go about calculating how far you walked based on the number of steps you took in a given day? Write out your directions for calculating the distance walked in a given day. Be sure to make the directions specific and clear enough for anyone to follow. Well, let's see. I walk 2 feet per step, or 61 centimeters for all you metric fans. So that's the number of steps times 2 to get the distance in feet, or the number of steps times 61 to get the distance in centimeters. Number 4. Come up with a linear equation to determine your distance per day. Now this equation reads 2x equals d. The d stands for the distance in feet, and x stands for the number of steps. Since I walk 2 feet per step, that would be 2 times the number of steps, which would equal the distance. Number 5. Use your equation from above to determine how far you would have traveled if you walked 10,000 steps. Here's the equation from above. And here it is with 10,000 plugged into where the x was. Now, the equation reads 2 times 10,000 equals 20,000, and 20,000 feet is how far I would walk in 10,000 steps. Number 6. How would you go about calculating the number of steps you took based on the number of minutes you walked in a given time? Write out your directions for calculating the number of steps walked based on the number of minutes walked. Be sure to make the directions specific and clear enough for anyone to follow. Let's look at the screen. One of my steps take 0.35 seconds to take. That means to figure out how many steps I take in a given time, we would figure out how many seconds would fit into that time. Then we would divide that by 0.35 to figure out how many steps it would take. Number 7. Come up with an equation to determine the number of steps you take based on the time you walk. Here's the equation that I talked about just a moment ago, but with words to show you how it really works. The number of seconds divided by 0.35 equals how many steps. Number 8. If you walked for 30 minutes at a moderate speed, how many steps will you have taken? Use your equation from number 7 to calculate this. Well, 30 minutes is 1,800 seconds. So that's 1,800 divided by 0.35, which equals approximately 5,142. This means that I walk about 5,142 steps in 30 minutes. Now number 9. What number 9 wants me to do is to create a data table of my steps. Here is the data for 2 weeks, and the next step is to find an equation that represents this data. I was looking through it, and there is no equation because the day, let's say Monday is 1, Tuesday is 2, Wednesday is 3, and so on. The number of the day has no effect on how many steps. So I can't make an equation relating the two, day and steps, because they're both independent. This isn't linear because there's no equation that's gonna make it always the same relationship between x and y, and this is because they are both independent sets of data. This leads us to our next question, which is question number 10. Here we have to graph our data and then identify our independent and dependent variables. I've concluded that both of the variables in this graph are independent because one does not have an effect on the other. However, after creating the line of best fit, there are independent and dependent variables. Now the independent variable is x, which is the day, and the dependent variable is y, which is the steps. Here I have the 2 points that I'm going to use to find out the equation. And here's the equation after I've solved it. Y equals negative 7.7x plus 14,907.7. The y stands for the number of steps and the x stands for the day. This equation does not match my data table because my data table is not linear, whereas this one is. Now let's move on to question 11. What is the rate of change for your line? Part A. What information do I need to calculate the rate of change? The information I need are just 2 points from the line and their x and y coordinates. So here I have the first and last point, 1, 14,900 and 14,800. Part B. I would know as soon as I saw these numbers that it would be a negative slope because the y coordinates decrease in value. C. Which points on the line did you choose to help you calculate the rate of change and why? I chose the first and last coordinates because it was the easiest to see how much the y value changed. So after this, I got negative 100, which was the change in y, and divided that by 13, which was the change in x. Then I got negative 7.69230769, and it went on. What I did was I rounded it to negative 7.7 so that it is much easier to work with. In this situation, the negative 7.7, or the slope, represents the change in steps I have every day. And in this case, it's about 8 steps less every day. Now we have the final question. I need to answer our unit question, how do we model change? We can model change in many ways. We can use tables to show the dependent and independent variables, and we can use graphs to show the change visually. To show change over time, we must show the change in time and the change in data so that the two can be compared. To model change, we must find the rate of change as well. This way, we can show how much it is changing and at what rate. I believe that the most efficient way to model change is with the use of graphs and tables because they show the changes in a way that is easy to understand.